Alright, this is section 6.3, areas under any normal curve. We're going to play kind of a game today, and I'm sure you guys all love hearing that when I start off saying that today is all about being game day. So what are we going to do? We're doing basically the inverse, or the opposite, of what we did in the last section. So in the last section I gave you a z-score and you had to find the probabilities. Well, we're going to do kind of the opposite. I want to find the z-score when I give you the probabilities or the areas in a given situation or a given period. Okay, so we're going to either find a raw score or a z-score that corresponds to this given area. So to do this, you take your table. So you need to find your table. We're going to look up the probability that they're asking for in the table and then find that corresponding z-score. So it's just kind of a game. Oh, I should probably go back and talk about this one. So what's this one saying? I want to find a z-score such that the probability to the left of my line is 89.07 or 0.8907. So here's what you got to kind of put yourself in this scenario. Since I'm to the right of the mean, my z-score should be positive. I hope you agree with me on that. And if that's the case, grab your z-table, go to the positive side, and if you guys notice that it's 0.8907, that's pretty large. So it's going to be relatively in the middle somewhere. And what you need to do is just scan through your table, and the more you do this, the easier this is going to be. Find the number that is closest to or right on to, and since it's the first one, you know it's going to be right on, 0.8907. So 0.8907, if you notice, will line up in the column that's 1.2, and the top that is 0.03. If you follow them over and down, what is your z-score then? 1.03 or 1.23, excuse me. So that is the z-score. That's how that works. That's as easy as the game is. If you can find the number in the table, okay, you just follow it over, and whatever that z-score is, you win. So let's see if we can win on the rest of these. They get kind of tricky though. I want to find, actually I'm doing the hard ones first, by the way, to kind of throw a little shift in it. If you can do this page, you can do the rest. I want to find the z-score that you get in your table so that the probability to the right of it is 63.31%. Now why is that tricky? Hopefully in your mind you're thinking, well, z-scores give me the information to the left and only left. So how do you figure out the number you need to look for in your table if your table only gives you information to the left? Think complement. Here's my line. I want left, but they only give us the rest of it. So you might need to work the complement. If I go 1 minus 0.6331, I get 0.3669. That was unfortunate. 0.3669 is the probability in this little shaded area. That's the number I'm looking for. So go to your z-table and see if you can find 0.3669. Hopefully you can go, okay, it's on the negative side, and that number is found directly at negative 0.34. So that's how you go about doing that number right there. Now the next one. I want to find the z-score, now that's the left side here, this is the line I'm looking for, such that the probability to the right of it to the mean, so to the right of it only to the mean, is 47.93. So there's a couple ways you need to look at this. If this is kind of an interval idea, it's 47.93 from 0 to this magic z-score. I know that my mean is exactly halfway in the middle. So 50% is from that mean to the left. Okay? And I now want to kick out this 47.93 because what I'm looking for is actually to the left. So once again, it's kind of a complement idea. What does this part need to be so that this whole thing adds up to 0.5? Alright? That's that 0.0207. So then I know it's negative. I know it's relatively small. Should be a relatively large negative number, if that kind of makes sense. And if you go to your table, negative 2.04 will give you that exact number. So kind of you need to put yourself in the scenario and think about what area are we looking for. So another one, I'm now throwing it over to the positive side. I want to find the z-score on this right side here, so I know it's positive for 1, and I know it's pretty big, because from that magic line to my mean is 49%. Alright, so that means not only is that 49%, but the z-score from my table is going to give me the information from this line all the way to the left. Okay, and if that's the case, what are we going to do? We need to add this stuff that's not included. Well, how much is to the left of the mean? 0.5000. So all I need to do is add those two up. That means from the line we're looking for, that z-score actually needs to give us 99%. So if you go to your table, it would become, now here's where I'm purposely finding these. It's going to be 2.33 because where does this 0.99 fall? It falls exactly between two numbers. Well, if it's not exactly between, find the number that it is closest to. Since 0.9901 is closer to 0.99 than the 0.9898 is, then you use the 0.23 or the 2.33 z-score. That's why that one trumps in this case, because the 0.9901 is closer to the 0.99. If it becomes exactly between, I'm going to give you an example right here. Okay, you would have to then go and find the average between them, only if it's exact. This one wins because it's closer. So this last problem on the bottom, I want to find the z-score that gives me exactly 0.005 to the left of that line. Well, what z-score gives me that? Okay, well, since it's to the left, I just need to find that in the problem. And here's what you need to do. 0.0050 is exactly between these two numbers. So if you go to your table and find the information that's exactly between it, you then have to go up and find, okay, it's exactly between negative 2.57 and negative 2.58. So then your z-score becomes negative 2.575. That's the only time I will ever expect you to have a z-score that is not rounded to the hundredths place. Okay, we then go to the thousandths place. Only when we are finding the z-score this way. When it ever is exactly between. The amount of times that actually happens is very minimal. You usually will have more of the scenario up there where one is closer than the other, so that's the z-score I am looking for. Here on a test or a quiz, it's imperative that you do show your work. It might be beneficial for you. Okay? For grading on notes for this section, I want you, as you walk into class, the next day we have class, to on a slip of paper, what is your favorite holiday and why? Tell me why. Whatever holiday you deem as the greatest holiday is your favorite, and please tell me why. Alright, back to notes. Find z such that 95% of the curve, that should be of, whoops, that's a typo, of the curve falls between negative z and z. All that means is, what are the two z-scores, one negative, one positive, such that 95% of your data falls in between them. So, alright, now how do I do this? Well, how does a z-score work on your notes? The easiest one I can think of is this far left one. Alright, that z-score is going to give me a number that gives me this tail. Well, if 95% is in the middle and it's symmetrical, that means what? 5% is left over, so half will be on each side. So the 0.025 on this side, 0.025 on that side. And that's what I'm going to show you here. Is I know there's 5% left over because I want 95% in the middle, and then I'm going to step up one more and say, you know what, half is on the left, half is on the right. So if I can find this 0.025 number in my table, that's my z-score. Now, if you notice, if you make 95% and think about it, that's your empirical rule, 2 standard deviations each way. Look how close this number is. Mathematically, it's negative 1.96. Very close to 2 standard deviations to the left. And what's pretty neat about this, and you guys know I like using the phrase pretty neat, it's symmetrical. If this one's negative 1.96, take a wild guess what this one would be on the right. Okay? I want to say, you know what? I want 95% plus that 2.5%. Find the number 0.9750 in your table. It's the positive 1.96. So you do not have to look up both of them. They are symmetrical. If you have 95% and it's going across the mean like that, it's going to be a negative and a positive of the same number. So between negative 1.96 and 1.96 standard deviations each side is 95% of your data if we mathematically figure it out. If I ask for the empirical rule, you can say the negative 2. So here's an application. So let's say last year's scores on this Chapter 6 test that we will take next week are normally distributed. The mean score was a 75. The standard deviation was a 5. So if the mean and standard deviation happen to stay the same as last year, I want to know what's the probability that your score between 75 and 85 on the test next week, that you will actually score that. What is that probability? Okay, so what you need to do is take these raw scores, change them to your z-scores. Alright, so that's pretty simple. So if you go in, this is just like we did before, this is kind of like yesterday. That's between 0 and 2 standard deviations each way, correct? Because I know that my standard deviation is 5, so 1 standard deviation would be 80, 2 standard deviations would be 85. So that's the idea. If I calculate it out, if you get 2, it's 97.7. Write on your means, subtract 50%, you get 47.72% chance of you falling or testing in that range. So that's kind of working with your normal distribution, going that route. So that's giving you the raw scores, and then you finding a probability. Here's the application of this section. What if I decide that anyone who scores at the top 4% on the Chapter 6 test is done? You're going to receive, I spelled receive wrong too. So you're going to receive an A on everything for the rest of the semester. Game over. If you get this chapter, winner, winner, chicken dinner. What is the minimum score that you must earn on the test to guarantee yourselves an A if we go back to the same information as last year? So the average score or the mean was 75. Standard deviation is 5. I need to find a raw score. This is tricky. First of all, do you know the mean? Yep, 75. Do you know the standard deviation? Yep, it's 5. Do you know your z-score that you need? Nope. That's the game you have to play in this section. What do I want? What percentage are we talking about? I want anyone in the top 4%. So if you draw this thing out, I know that whatever z-score I need needs to be in the top 4% or to the right, the high 4%. So what number are you going to look for on your table? Do I want to find 0.04 on my table? No. I want to find the information that's to the left of that number. What do I not want? I do not want to be in the 96% of the rest of the class, because then I have to take all these tests. And no, this isn't for real. This is just an argument type problem. Okay? What is that z-score? If you look and find 0.9600 in your table, the z-score is 1.75. Once you establish that, okay, I just need to be 1.75 standard deviations above my mean. So what's 1.75 times 5? Add 75. You would have to get an 83.75% on this test given the same mean and standard deviation. Now, that does not mean it's a score like you think. It's based on your class's average and stuff, but if you were in last year's class taking last year's test, that's the score you would have to have in order to earn an A the rest of the semester. So there's an application problem for you. We will see a lot more in our notes or in our homework in class tomorrow. You guys have a wonderful day.